Okay, let's continue. We are going to have a look of the programming model for the Nvidia SXM and AMD OAM modules. I mean, the computing system with these two kinds of modules. Um, we have mentioned that for the GPU computing systems with PCIe adapter GPUs, the programming model is the MPI plus the peer-to-peer memory access. The MPI plus peer-to-peer memory access programming model works with this new GPU computing system with SXM and OAM modules. It works. But with this kind of intro GPU communication networks, I mean the connections between the GPUs connected to the same host, this kind of NVLink network. With the addition of this NVLink network, it means the peer-to-peer memory access, they don't need to go through this PCIe network anymore. And because the NVLink has much more bandwidth than the PCIe links, so peer-to-peer MPI plus peer-to-peer programming model that was used for the GPU computing systems with PCIe adapters still works with these new computing systems with SXM and OS modules. But because the increased benefits of the NVLink is getting faster, is going to benefit from this new architecture. But for these new GPU computing systems with NVIDIA SXM and AMD OM modules, the most appropriate programming model is no more MPI plus peer-to-peer memory. It should be MPI plus NICO. This should be the programming model for this kind of systems. Okay, now let's have a look of this programming model. This programming model, we have two paths. The first one is the MPI, the second one is NICO. So let's have a look the first. I have redrawn this scheme to make things more clear. So for the MPI part, this is the MPI part. This is the MPI part. So we have MPI tasks. This is the MPI task. And you have threads, OpenMP threads. The communication between the threads is shared memory. The threads can access the shared memory. If this thread A has something to pass to thread B, what it needs to do is that it's going to put the data in the shared memory, and then thread B needs to go there and read this data. That means the data has been passed. I mean, it's not physically passed from A to B, but the data can be accessed by B, and then B can access this data. It's kind of communication. It's kind of implicit communication between N and B. That means by access the shared memory. So that's for MPI for threads. But for the two MPI processes, for these two MPI processes, the communication will be going through the network by using the MPI. So what the system need to do to make sure this communication is going to happen is that if you have a piece of data to be passed from this node to the other one, here, for example, you need to pass the data from here to here. What the system needs to do is that really the data, really the data need to be sent explicitly from this node, from the right-hand side node to the left-hand side node, okay? Okay, so what the system is going to do, the system is going to tell the InfiniBand adapter, if we are using InfiniBand, is going to tell the InfiniBand adapter I have a piece of data which is located here. This piece of data need to be sent to the left-hand side node and need to be put somewhere here. And then the InfiniBand adapter is going to use the DMA technology, direct memory access, goes here and get this piece of data, and then push the data into the network. And then because the network, the InfiniBand network, the routing has been done, then the network knows where the data should be sent to. If you are telling the network that the destination is the left-hand side node, and then the network can send this data from this InfiniBand adapter by going through the links and all the switches and all the way here to the destination adapter. This adapter is going to put the data here by using the DMA technology. So it's direct memory access talk technology. The InfiniBand adapter is going to put data here, and then the communication will be done. This is the explicit communication, because we have the data physically being sent and being received by the receiver and goes through this network. This is the explicit communication between the two nodes. Okay, and there is one point is that for this kind of MPI communication, there are two types of communication. There is one type is working with the memory located in the host, and this is going to be done with even with this non-GPU aware MPI library. There is another kind of communication is that if the data that you want to send from the right-hand side to the left-hand side node is located in the GPU memory here. Suppose it's here. This is the GPU memory. This is the data you want to send, and you want to put it here. This is the data here. I'm sorry, the color is not so. Let me change the color. So what you want to do is the data here need to be sent here. And in this case, the MPI, you cannot use the non-GPU aware MPI library. You have to use the GPU aware MPI library, because here only the GPU aware MPI library can work with the GPU memory. So in this case, everything will be same, except that this InfiniBand adapter needs to have DMA to the GPU memory, and at the left-hand side, the InfiniBand adapter need to have DMA to access the GPU memory, and only GPU-aware MPI library can work with the GPU memory. So for this is the MPI part. This is the communication. This is the MPI part. This is the MPI part of the programming model. This is the MPI part. Now we need to pass to the NICO part. Okay, for NICO communication library, conceptually is the same as MPI. Let's see, this is the NICO. This is the NICO communication. And we can think that each GPU is a task. It's something like a NICO task. Okay, you can think that this NICO task is the same thing as MPI task, because each MPI task, into an MPI task, you can have multiple threads. And the same thing is that into a NICO task, you can have multiple GPU threads you can have multiple GPU threads. And I have mentioned in the earlier sections that you need to have lots of GPU threads, minimum 1 million GPU threads per GPU. And then suppose you have multiple GPUs connected to the right-hand side nodes. And the same story is that you have multiple GPUs connected to the left-hand side node. And each GPU is conceptually is like a Nico task, is like an MPI task. And then it holds lots GPU threads. So these Nico tasks, they need to communicate each other, intra-nodes and inter-nodes. Okay, intra-nodes is simple. There's you need to go through this NVLink network. So this is Nico communication intra-nodes. Okay, inter-nodes, things are getting complicated because inter-nodes, you don't have this Nico NVLink network. You have only InfiniBand network. So the communication has to go through this InfiniBand network. So the communication, communication will be two paths. Intra-node communication between the tasks goes through the NVLink. Inter-node communication between GPU Nico tasks. We can simply say that inter-node GPU communications are going to go through this InfiniBand network. And to access this InfiniBand network, the GPU need to because the InfiniBand adapter is connected to the GPU by the PCIe link. So to have this kind of inter-node communication, you need to go through this PCIe link. This is the PCIe link. You need to go through this PCIe link, and it's getting things complicated. And it is even more complicated when the GPU1 wants to communicate, and the communication is going to go through the NVLink network, and then reach the GPU0, and then go through the PCIe link, and reach this InfiniBand network, and then goes this InfiniBand network to reach the left-hand side. That means the message, the communication need to go through 3 kinds of networks. Okay, that's going to make things more complicated. But Nico has been designed to work with this kind of network setup. It has been designed to cope with these 3 kinds of network technologies. So we finally, from the programmer's point of view, what we can understand is that, okay, each GPU is a Nico task. Intra this GPU, there are lots of GPU threads, and you have GPUs connected to the same node. Intra these GPUs connected to the same node. For example, intra these GPUs. Between these GPUs are connected to the same host. Inter these GPUs, communication could go through NVLink, and inter the GPUs, the right-hand side group of GPUs and the left-hand side group of GPUs, between these 2 groups of GPUs, the communication has to go through this InfiniBand network. And it has to go through the 3 kind of links. If GPU 0 has to communicate with GPU 0 from the left-hand side. GPU 0 from right-hand side has to communicate from GPU 0 from left-hand side. You don't need to go through the NVLink because you go directly, you pass this PCIe, you are going to reach the InfiniBand, and you are going to reach the destination, and you pass this PCIe link, you are going to reach your destination. But if GPU 1 from the right-hand side needs to communicate from GPU 0 from the left-hand side, the message need to go to pass this NVLink network, and then goes down and pass this PCIe, and then pass the InfiniBand network and reach its destination. So it needs to pass 3 kinds of networks. So this is how it's going to be done. So to make things simple, to summarize, there are 2 sets of communication libraries. There are 2 sets of communications for this kind of programming model. There is the MPI communication. There is also this NICO communication. MPI communication is for MPI tasks. This is the inter-MPI task communication by using, is going to use this MPI library. Inter-GPU or inter-NICO tasks or inter-GPU communication for intra-node GPUs and for inter-node GPUs is going to be done by using the NICO library, by using the NICO communication scheme. That could be using the PCIe plus InfiniBand, or it could be by using InfiniBand plus PCIe even plus the NVLink, goes through these 3 kinds of networks. So basically, the summary is that for this programming model, you have 2 sets of libraries, and each library is taking care one kind of the communications. MPI is taking care of the communication between the MPI tasks. NICO is taking care of the communication between the GPU, between the NICO tasks. So it's kind of mix of these 2 kinds of schemes, 2 kinds of libraries, 2 kinds of methods. But there is one point I need to point out is that NICO doesn't work by itself. It depends on the MPI library to help itself to set up the communication infrastructure, to help it to set up the communication environment. So that's the reason why in the official documents comes from Nvidia and AMD is clearly saying that you have to use MPI and NICO at the same time to deal with this kind of complex communication patterns. Okay, so this is the communication structure. Communication program, the communication infrastructure is kind of mix of the 2, is the choice for this kind of GPU computing systems with SXM and OM modules. Another thing I need to point out is that NICO communication by nature is realized, meaning that the communications are grouped into reals. That means the communications won't cross the reals. That means this InfiniBand adapter won't communicate. The right one won't communicate with the green one from the left-hand side. The right one won't communicate with the green one, and it won't communicate with the yellow one. This red one won't communicate with the yellow one. So the NICO communication is by design is going to be grouped into rails. That give us the that means that the network for the NICO communication is going to be the network for the NICO communication should be also in rails. That means I'm going to use this example to explain this point. Suppose you have 64 nodes, and each node you have 8 GPUs, and you have 8 InfiniBand adapters. This is the InfiniBand adapter. You have 8 InfiniBand adapters. So, because by nature the NICO communication is by rails, then that means to build up the communication network, the InfiniBand network for this NICO traffic, you can use this kind of network in rails. That means you have one switch. For example, this is the 64 port switch, and is going to be connected to the right NIC from each node. So from the first node, from the second node, you have 64 nodes, and the switch, you have 64 ports. So you are going to use all these 64 ports, connect to always to the first NIC of these 64 nodes. So this is the red rail. And then you are going to have this green rail. Means you take the 64 ports, you connect each port to a different NIC from a different node. So, but you always connect to the second NIC. This is the second NIC, the green one. So you are going to use up these 64 nodes of this switch, and then you are going to have this green rail, and etc. etc. At the end, you are going to have the yellow rail. At the end, to cope with the NICO traffic, this NICO traffic, what you need to have is eight switches, and each switch is going to have 64 ports. Okay, this is what you need to have. So this is the NICO, the InfiniBand network. For NICO communication, you can build up this kind of network by using the concept of rails. You can separate the network into different rails. Okay, if there is also another way to do this network is that you don't distinguish the rails. If you decide to build up a network, a factory network, a traditional factory network for this NICO communication traffic, and what you are going to end up is that you need to have the edge switch, and depend on this the quantity of nodes, because our example we have 64 nodes. So 64 nodes, and each node you have 8 links. So you are going to have 512 links, uplinks. And to connect these 512 uplinks to the edge switch of the factory, you need to have 16 edge switches. Okay, 16 edge switches. Okay, the edge switch will have 32 downlinks. Okay, and it's going to have 32 uplinks. Suppose you have 64 port InfiniBand switch. Okay, and then 32 uplinks. If you want to build up this factory, and you need to have the core layer of switches, And to have this factory network, you need to have another 8 switches. That's core switches, 8 core switches. So you will end up by using 24 switches, InfiniBand switches. Each switch is 64 ports to build up this factory for the NICO traffic. But the fact is that because the NICO communication is divided into different reels. The fact is that if you build up this kind of factory for this kind of factory network for the NICO traffic, for this NICO traffic, you will end up with very few traffic goes through the goes through the core layer switches. Okay, very few. You are going to have very few traffic here going through these core layer InfiniBand switches. You have 8 of them. And most of the traffic will be going through the edge switches and reach its destination because the communication by concept, by design, is by reels. So that means for this kind of NICO communication, really, if you build up this kind of factory network for this NICO communication, if you choose to use this factory, you are going to be wasting your resources. I mean, you have more links, you have more cables, you have more switches, but the NICO communication, they won't use all the communication capacities. That means the NICO communication won't use all the bandwidth of the factory network can deliver to you. That means you are wasting the resources. So this kind of after we have understood that this kind of communication, this kind of NICO communication has been designed to be separated into reels. That means for us, for the system vendors and for the suppliers of the systems to the users, you can choose to use this kind of network. It's not a factory. It's low cost. You have less switches. You have less cables, but the communication can be done, and is going to make the NICO communication satisfied. Okay, this is basically the things we need to learn from these technical details of the NICO implementation. Okay. And then just the last word is that you are going to have, let's see for this example, you are going to have 8 reels. Okay, 8 reels for the NICO. For NICO. 8 reels for NICO. Because this programming is a kind of mix, it's kind of a mixed programming model. It's MPI plus NICO. So for the MPI traffic, for the MPI communication, because you have 8 reels, or for MPI communication, MPI traffic, they need just 1 reel to realize this communication. So the system vendor, they have a choice to put this MPI traffic on the red one or on the green one or on the yellow one, but you just need to have 1. You just need to use 1. This is the for the MPI traffic. Okay, so we need to summarize this section. So this section, the first topic we discussed is that with this kind of GPU, with this kind of SXM and OEM modules comes from Nvidia and AMD. The MPI plus peer-to-peer programming model that works on the computing systems with PCIe adapters can be made faster because these peer-to-peer memory access, they can benefit from this added NVLink or InfiniBand. So the MPI plus peer-to-peer programming model is going to benefit from this one. It works with the GPU computing system with PCIe adapters. It also works with computing system with Nvidia SXM and AMD OEM modules, and it's going to be faster. And then the second point, by going through a short piece of code, we have discussed the intra-node collective GPU communication, and it's by using the NICO library. Is using the NICO library. So the NICO is by using the NICO library and by using the NVLink network. So this NVLink network can be used to pass this peer-to-peer memory access traffic, and that's NVLink can also be used by this NICO communication scheme. And for inter-node collective GPU communication, you have to use the NICO. And the peer-to-peer memory access is limited to intra-node GPUs. So it cannot be used on this kind of computing system with SXM and OEM modules. It cannot be used on this kind of computing system to go across nodes. To go across nodes, you have to use the NICO communication library, and NICO communication library is going to make use of the NVLink. NVLink is to use the NVLink, the PCIe, and the InfiniBand. Is going to use these three kind of network technology to make the communication happen. What I mean is the inter-node collective GPU communication. Okay, and then we had a look at these NICO implementation details. And we from these implementation details, we understood that NICO relies on MPI to function correctly. It doesn't work without the help of the MPI. And NICO is complementary of MPI. So basically, this programming model, MPI plus NICO, is the choice for the GPU computing systems with the SXM and the OEM modules. Okay, and in this part, we also discussed that NICO communication by design, by conception, is in reals. The traffic itself is in reals, so there is no need to build up a fully connected fat tree to pass these NICO traffics. Because by design, by conception, this NICO traffic is in reals. So what you need to do is to build up a network, an InfiniBand network in reals to pass this NICO traffic. That's enough. If you go and build up a fully connected fat tree, you are going to be wasting the resources. You are going to have the bandwidth available for the system for the NICO traffic that cannot be fully utilized. So this is something we need to learn from this discussion. And the summary is that MPI plus NICO is the programming model for complex collective communication patterns, which involves both intra-node and inter-node GPUs. Okay, so MPI plus peer-to-peer memory access, the programming model for traditional GPU computing systems with PCIe adapters, can still be used on this generation of GPU computing systems with SXM and OS modules. But it can benefit from the NVLink or the Infinity Fabric link to make their peer-to-peer memory access faster. So it's beneficial for them, but the right choice to deal with complex communication is this MPI plus NICO programming model. Okay, by this summary, I'm going to stop here. I have finished the section 4. It has been it has been broken into 5 parts. So now it's totally done. Okay, let me stop the recording, and we are going to continue our discussion in section 5. And section 5 is getting more interesting, challenging, and complicated. Okay, see you. Bye-bye for the moment.